Welcome everyone, thank you for joining. Get yourself ready, grab a notebook, a pencil or a pen, anything you want to write with is fine. This is math from the void, math coming at you out of nowhere. Today we have a nice problem from the 2008 Calculus BC exam. Even though it's from the BC exam, it's totally approachable by AB students, so give yourself some moments, maybe 10 to 12 minutes for this one. Soak in the problem, give it a try for yourself, and then when you're ready you can join back, because here we go. We see a graph given. This is indicated to be the graph of the graph of V. That's the velocity of an object moving. And we don't have an equation for this. It does look kind of cubic potentially, but we cannot assume anything about the equation. And we're told that it's 0 at these particular spots, so that's kind of helpful to have those exact points as zeros, 0, 3, and 5. If the velocity is 0, that means the object is not moving at those times. And we're also told that this graph has horizontal tangents at t equals 1, so there's a flat point, and also t equals 4. So there's another flat point. It even gives us the areas of the regions, which is kind of nice. So it tells us the areas of these regions are 8, 3, and 2. That's in between 5 and 6, so let's kind of draw this here. And I've written these in red because this is when the velocity is negative, therefore this is representing when the object or particle is moving backwards. And the number inside, the area, much like the integral of the velocity, is telling us the displacement over that time period. Okay, great. We're also given an initial condition here that we cannot ignore. At time t equals 0, the particle is at this location, x equals -2. So I might even write it more clearly that x of 0 equals -2. Okay, part A says, find both the time and position of the particle when it is farthest to the left. Find both the time and the position. Okay, so let's think about this. If the object starts at -2, let's keep track of its position. At 0 seconds, the object is at a position of -2. At 3 seconds, the object has moved 8 units to the left, so now the position is at -10. That's going to be the leftmost position, furthest to the left. But let's just continue with some other interesting positions. At 5 seconds, the particle has moved to the right 3 units. And then at 6 seconds, the particle has moved to the left again, but only by 2 units. And so its furthest left location is going to be at this time and this position. So we would say, I guess we can say the time first. We can say at t equals 3. And then we can say x of 3 equals -10. Great. For how many values, it doesn't ask for which values, it asks for how many values of t from 0 to 6 is the particle at a position of x equals -8. We're going to use something called the Intermediate Value Theorem to keep track of when the position would have crossed -8. So from 0 to 3 seconds, we go from -2 to -10. This definitely crosses -8 at some point. And then from 3 to 5, the position goes from -10 to -7. So again, the position had to cross through -8 when it's becoming more positive. And then from times 5 to 6, we get that the position is -9. So again, we have the position going through. If we were keeping track of the position, we might do something like this: -2, and then at 3 seconds, here's our threshold of -8. Here we have crossed the -8 at some point. We don't need to know exactly what time it happens. And then at 5 seconds, we're a little bit above this line. So we will have crossed again this line. That's the second time. And then at 6 seconds, we end up at -9. So we would have crossed yet again. And that makes for 3 crossing points. So just being really clear about that, I think you could just solve it pretty easily by looking at this chart. So we would say 3 values of t, and if they want us to explain, we can use the intermediate value theorem here. By the IVT. Okay, part C. Moving along quite quickly, aren't we? On the interval from 2 to 3, is the speed increasing or decreasing? So we need to understand how we determine that. How do we determine if the speed is increasing or decreasing? Remember that speed is increasing if the velocity and the acceleration are the same sign, whereas it's decreasing if the velocity and the acceleration are opposite signs. So we need a way to determine the plus or minus sign of the velocity and of the acceleration. Now the velocity is just given on the graph. So let's take a look from 2 to 3. From 2 to 3, the value of the velocity is negative. So we can say v less than 0. Now what about the acceleration? Remember that the acceleration is the derivative of velocity, which means it's the slope. And from 2 to 3, the slope is clearly going upwards, so it's positive, which means the velocity is negative, but the acceleration is positive. That indicates that it is slowing down. Another great way, this is sort of a pro tip, another great way to determine if something is speeding up or slowing down, and you're looking at the velocity graph, speeding up means that the velocity is getting further away from 0. Okay. Which makes sense. If I'm going fast in a positive sense, and my acceleration is slowing me down, then I'll be getting closer to 0. And if my velocity is going further away from 0, meaning if it's positive and it's continuing to go more positive, or if it's negative and continuing to go more negative, that would be speeding up. Whereas slowing down, in other words, the speed is decreasing. That's the same thing as slowing down. That would mean the velocity is getting closer to 0. And so you can look at the graph of the velocity from 2 to 3, and you can notice that at that point it's getting closer to the x-axis, which means this is definitely slowing down at that time. Yeah. Oops. To sub-zero, not sub-zero, 0. Okay, so this is clearly slowing down. The speed is decreasing. Speed is decreasing from 2 to 3, or I can say on 2 to 3. Okay. During what time intervals, if any, wow, really easy questions here, guys. During what time intervals, if any, is the acceleration negative? So this just means the slope is negative. Okay, so we just have to look. The slope is the acceleration in this case because the graph is the velocity. And again, the derivative of velocity is acceleration. So let's look for when there's negative slopes. I might do it in this kind of funky color, like a yellow. I see that it's going down. The graph is going down from here to here. Then the graph is going up, 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 up until t equals 4. And then the graph is going downwards again. So this is going to be on the interval from 0 to 1 and from 4 to 6. Really easy question here, guys. This is like a particle motion question, but it does have you understand the connection between the derivative, the integral, using the velocity, position, and acceleration. So they've given us a graph of the derivative of the position. We have to figure out the position by using these areas, which they graciously gave us. Make sure that the negative ones below the x-axis are used as negatives. And the acceleration as well is the slope of the velocity, therefore the slope of this graph, all right? So pretty easy, just had to use the IVT, didn't have to even take a derivative or take an antiderivative. We just had to use knowledge about the derivative, that it is the slope. All right, that's enough blab out of me on this short ride. See you guys next time on the void.